Okay, so I had an idea, which is to before I go and continue making more progress on the filtering thing, because I'm too tired to do that right now. But I was like, I'm not too tired to actually look through the video of me that I recorded earlier today doing that and just see like if I can like review myself as I'm programming, like knowing what I know now about the rabbit holes I went down and where I got stuck. I can now criticize my former self in a very like meta way. So that's what I'm gonna do. So how do I do this? It's pretty. Before I move on, how crazy is that? Isn't that weird? All right. Um, so let's see. I've got VLC up, and I guess I don't need to have the volume on here, but let's play this guy. So let's see. Um, where do we start? So I start off by showing like what the difference is between filtering and searching. Um, and then what? Yeah, so I thought, okay, so we kind of started in the right place. So we've got this branches context thing. And I was hoping to use this list context trait as some place to like have some centralized code for supporting filtering. What else we got here? I was looking into the different models involved. Oh yeah, my initial plan was to have kind of two different ways of registering what the current line is. There's like the current line when you aren't considering filtering, and the current line when you do consider filtering. So I was kind of wrestling with where would be the right place to have that distinction encoded. And throughout the video, I never actually worked out like whether I needed to do that. I still, it still intuitively seems to me like you would have to do that at some point, but somehow I was able to get away with just, doing a pre-filter step, before we enter all this code here. So I think it's going to become clearer once there's more like different ways you have to actually interact with the lines. Like for example, if I like filter down and then I want to do like a rebase or something like that, there's going to be situations there where we're either going to have to just like prevent you from running certain commands, or we're going to have to find some way of mapping from the current selection back to the actual unfiltered list. So that's an unsolved problem that I never really got to the bottom of here. So here I am just continuing to dig around and trying to work out what is the existing logic and where would be a good place to put this thing. So how do I speed this up? 3 times speed, take me back to uni days. Okay, so still clicking around, not really making much progress. 8 times speed. Talking more. How far? 16 times speed. Holy shit. Okay, so I find here that I've got my function that returns my branches, and I decide what if I just filter that. Okay, so and what I didn't realize at the time was that this thing here also would need to be filtered, so that we're both actually displaying the filtered list as well as constraining the cursor to the filtered list. And here I'm using Lodash, not Lodash, but it's just called Low, but it's based on Lodash, which I think is a good initiative. I hope it's a successful project and lots of people start using it. Pardon me. Although obviously there are limitations to using that package, just because Go has some limitations around generics that kind of make things harder. Okay, so I'm testing the thing out and I find out that it's... Oh no, at this point it actually is working, so that's good. And then here I'm finding the searching file in the GUI, like the big GUI God struct, which, as I say in the video, is kind of unfortunate that it's still so big. Although, in the prior video to this original one here, I was walking through some code that was a lot less tied to that thing. So I spent a lot of my holidays actually refactoring this to break down what was this God struct. Because back when I started Lazygit in 2018, it was my first Go program ever, so I had no idea what I was doing. And so I did kind of let this God struct get a bit too big. And yeah, I ended up spending a bunch of my holidays refactoring it to kind of fix things, but it took so long, and there was these PRs I had to review. I didn't want to have to keep getting like other contributors to have to like rebase. I didn't want to have to. That's part of it, but I didn't want to have myself constantly mapping new changes across to the refactored code, given that it was likely to cause bugs. So I ended up merging what was a pretty substantial refactor, but it's just unfortunate that, that there's a lot more that could be done there. So here I am trying out this, trying out an approach that gets around the fact that you can't have generic methods on the GUI struct. And so I'm thinking, well, I don't technically need to have and the reason you would want to use a generic is so you can say like, here's a method and I can use it in the context of commits or in the context of branches or the context of files, and those are all different types, so you want to pass it in as a type parameter. And I was thinking, well, maybe I don't need to process that. Maybe I could just deal with like an array of integers. And so here I'm kind of experimenting with that. I'm going to pass that into the display strings, and then within the get display strings function, I'm going to take the list and then kind of just restrict it based on that array of the slice of integers, the slice of indexes. Let's see, where's my cat going right now? But I kind of stopped doing that halfway through because I worked out that, just letting my cat out. I stopped halfway through because I figured that it's going to require a lot of duplication within all of these bespoke functions to get my display strings that I need to go and make this extra function call to filter things down. So that felt wrong to me. I also didn't feel good about the fact that I was using this like kind of arbitrary slice of indexes to get around the lack of using generics. It may still be that I'll need to have something like that when I have to like map back and forth between the filtered indexes and the non-filtered ones, but I don't think here is the right place for it at any rate. And just as a thing that I might not have explained that well during the actual original video, get display strings returns a slice of a slice of strings, because it's giving you like a bunch of columns to render. So in Lazygit, see how here, for example, like that's a column, that's a column, that's a column. So there's like a bit of code that goes and aligns the columns so that they're all in the one line. So that's what that's for. Okay. So I'm currently kind of trying that out, but I'm not deciding that it might not be the best approach. And now I'm thinking like, what do I do? I Google some things. Yeah, I give myself a reminder on how to use generics. So here I'm saying, okay, let's just use generics. We'll make the list context thing actually generic, and then it will be able to, what's it trying to do here? Okay, so I'm scratching my head. I'm thinking maybe not the list context trait. Yeah, so I'm trying different things. I honestly don't even feel that bad about anything so far. I mean, I think it's to be expected that you're going to just try different things and see what makes sense. My cat's meowing at me. Okay. Right, so here I'm dealing with the whole, the fact that we're going to have this new like filtering mode, searching mode. And And so I'm thinking just because the existing stuff there is kind of all living in this one package, that it's a good idea to do the same thing. But it was awkward because I had an existing struct that was taking care of that, like the search state, like what's being searched for and things like that. So I kind of got into a bit of trouble needing bits of information from either of those structs in different times. So what I ended up doing was like just putting them in the one thing, and it ended up being that this searching struct was just completely outside of the GUI package and inside the modes package. Although I still don't even know if modes is if it makes sense for that to be a package, just because it contains very disparate things. But the important thing is that the searching struct needed to live somewhere, and I like to put things in a separate package when I can, just because it enforces better encapsulation, so it's easy to change things. So what else we got? Oh my god, I can do 32 times speed. I guess I can it probably just keeps doubling. Wow. We're getting glitchy. This is just a freeze frame. It's almost like going at a certain speed actually slows it down. Reminds me of when you used to run like movies, when you used to like fast forward through movies, and it would take so long to jump from one frame to the next. It did beg the question of whether it actually would have been better off just going slower. I don't know if that's just an optical illusion or if that was actually true for some TVs. Okay, so we get to the fuzzy search thing. So I had to look at their README to see how to search for things when you're not just dealing with an array of, a slice of strings. Man, I wish they called it an array, or at least a vector, like Rust. I don't know why slice is so unmemorable. And the reason for this is that I could have gone and produced a slice of strings from my branches and then use the index of the match to map back to the branch. But I would just prefer not to have to go and like create this big slice of strings in memory when I could just iterate through each branch one at a time. So I had to kind of emulate this this employees example, but in the context of branches, and that seemed to work pretty well. It turns out you actually can cast a slice to like a typed slice, like this branches one, for example, without having to do anything, sneaky. Like, for example, with going from interfaces to concrete types and vice versa, you actually do need to go and explicitly iterate through it and reconstruct a new slice. So here's me using that low package again for mapping, and what else we got here? So I think it's working. Let's fast forward a bit more. Yep, that's me trying to make it explicitly satisfy an interface. And then I'm trying to work out how can I do this in a way where I can just have a simple interface from the dev's perspective of just having a single function. You give it whatever you want, whether it's branches or commits or whatever it is, and you give it the needle, the search string, and then it will return you back the stuff that's been filtered. So yeah, I wonder if I actually needed to use that oh, hang on, I gotta slow down. What I was gonna say is I wonder if I actually had to use that struct, or if there was some other way I could do it. So this is interesting because I put this thing in my utils. I think there's like a fuzzy search file in my utils package, and I'm testing this thing by using I'm just kind of wrapping a string in a struct so that we're forced to pass a anonymous function to take the struct and give me the string. So and I just kind of copied and pasted the test that was already there for when you're actually just iterating through existing strings. Now, one thing I could have probably done here is spent more time thinking about whether the original function for fuzzy search, which was just purely dealing with strings, whether that could be like, whether that could now call my new, more generic version, and like what whether A, that would simplify the code, B, whether there's like performance implications, like for example, it may be that it's just a bit more expensive to go and go through this more generic approach than if you already have a slice of strings. But if you could implement one and the other, and there's like no additional cost, then I think that's a good idea to do that. Yeah, here I'm kind of struggling to just update my tests to now have these structs, and now that I think about it, I could have used multi-cursors on the commas and then had the braces facing outside on both sides of the comma, and that would have easily done it. But I guess I just hadn't thought of that in real time. And it obviously cost me in time because I'm I'm flailing around not knowing why there's a compile error, because I know something's clearly wrong, but I just don't know where. And I'm kind of just fixing it as I go. So yeah, that took me way too long, and it would have easily been fixed by multiple cursors. There's probably some other way I could have done it where I just like tried to match on all strings, but I would have caught the needle side, which I wouldn't want to be in a string. So yeah, took way too long. Moving on. Okay, so we bring it back into here. Turns out that generic type parameter was not actually needed to be passed in explicitly, thank God. It's always good when you can use type inference like that. So, yep, I deleted that. And I was still unhappy with the fact that there was still a lot of code there that it wasn't obvious how I would actually go about applying that to all the other contexts that needed to have filtering involved. And by the end of the video, I didn't even really get to a point where I felt comfortable where it was like, felt like a solved problem. So in the next video, if I have the courage to go and record the continuation of this stuff, I'll need to try and find a way that I feel comfortable with, where it's actually a bit more elegant. My cat's clawing my own keyboard. This is the second cat this time. I've got 3 in total. So this is me saying, okay, it works for branches. What does it look like if I try and apply the same pattern to commits? So, and then here I am trying to, yeah, this is me showing that you actually can't use a generic type on a method, which is super annoying. And then I'm showing how it can cause issues if you include the graph, because none of these commits have parents, and the algorithm says I'm gonna kind of register, okay, you've got parents, your commit A, you've got parents B and C, I'll just draw a pipe that goes down, and then once I find either B or C, I'm gonna close it off at that commit, which in the typical, if you actually have things in topological order, it's going to look normal, but in this case, it just means you have this ever-increasing size of pipes that are like, where's the parent that I'm looking for here? I can't find it. So here, I think we're seeing some of the pain caused by having these 2 different structs that you query to work out what the search state is. So there's the modes.searching, and then it's just like state.searching, and that was kind of a pain. I also ran into trouble with the whole context versus context key thing. So I've written 2 long blog posts about type keys on my blog, and I still reckon that there are very few cases. Sorry, so a type key is just a key, like in this case here, local commits context key, which refers to some real thing that lives in code. And there are some situations where type keys make a lot of sense. Like the obvious one is where you're receiving it from like the user or from the outside world. So you can't send a function over, or a struct, or maybe a struct, but you can't send a function over the network, or at least typically you can't. And so what you would instead do is you would pass a key of some kind, like here's the function name and here's the arguments, and then you'd have a switch statement on the receiving end that maps that key to a real function in that language. And so whenever you have to serialize things, whenever you have to serialize things, it makes sense to use a type key. It's also called a type code I think Martin Fowler calls it a type code, but I feel like the word code there is not very helpful, so I say type key. But if you're not serializing something and you're not printing it out, like if you never have to like output it to a user, although in this particular case I actually did do that, then you should always ask yourself, what if I just lost the type key and just use the actual thing that it represents, given that this is all confined within my own program? Arguably I shouldn't have to go and use this key thing. I think one of the reasons I rely on this type key in this situation is because I don't have a lot of this code that kind of like sets up the contexts is it's running before the context exists, but it wants to have some reference to the context at the time that it's creating it. So in this case, the purpose of the type key is to be able to refer to a thing that hasn't yet been created. And I think that the better solution to that problem is just to find a way to create things in an order that is better, where you don't need to worry about whether something's been created yet, because there's like a more clear flow about like when can I expect things to be created. So I think there would be a way to resolve this, and I run into more trouble here when if I'm storing the key of the context on in my searching state, I get into a bit of trouble where if I then want to get that and map it back to the context, I have to have some kind of like a registry of mappings from context to keys. I suppose I could just iterate through them. I think that somewhere there's like a list of contexts. I can iterate through them and say which one has the matching key, but it doesn't feel like a very elegant solution. At the same time, it's not really like it's the worst thing ever to have some registry mapping from keys to contexts, but I would like to try and move Lazygit in the direction where I don't really have to have this like predefined set of contexts that are kind of hard-coded. I would like to just have things where just dynamically I can just create things and they've got relationships between each other and that all just works. So like for example, right now I can spawn a pop-up thing, say that you get like an error. I spawn a pop-up, and then you might want to have some other key binding that spawns another pop-up, and the problem is there's only one pop-up context, and just the fact that you can kind of have infinite contexts that are pop-ups, you would want that to just be a dynamic thing where there's no hard-coded key there, and you ideally can just go and create as many as you want, and then you can kind of pop them off the stack as you process whatever those pop-ups are. But currently we have issues because we're just assuming there's the one thing. Now that's not really necessarily, a difference, but that's not really, like you can have that. You can still have context keys, but keep them dynamic, but and you can like create some dynamic context key, but it still just feels wrong. Like it just, if you're going to, you make a key and you have like a auto incrementing number on it, in my mind, I think that there's still a way here to just have a context and say, I'm going to only deal with context, actual structs, and I'll do it that way. Of course, if you like, that probably also entails other problems where you now have multiple pointers referring to the one piece of data in memory. So which is something that like a language like Rust doesn't allow for. So I wonder how they deal with these kinds of problems. I wonder if they're more likely to use keys that refer back to a registry, because keys can easily be copied and it's not a big deal. Anyway, interesting. So yeah, here I'm saying these are my guys that have graphs, and I don't want to show my graph if I'm in filter mode, and if I'm applying that filter mode to one of these contexts with graphs. I create the searching in context function, but I find that later on it almost seems like it might have been a bit easier just to have the context key stored on the searching struct, for that to just be a public field, and I could just use this, for example, use low.contains to directly grab it. So I'm still not sure about whether that it's useful to have that method, because at least you can also encapsulate the fact that it's active in the first place, rather than having to go and prepend that to any condition that talks about whether a given context is being searched on. Also, one other thing I was thinking about is that there's probably, you may not even need to store the current context at all. So here I'm going in and saying I'm going to have a function, because I switched to using the type key, and I was like, damn it, I need to get my context. I don't yet have code that's like a registry mapping from the keys to the context, which I could have just done that, but I still felt like I guess my allergic reaction to type keys makes me not want to put too much more infrastructure around it within my code base. But this parent context thing, something I was thinking about was like, I could just have it so that I don't even store the context on my searching struct, and I just kind of know that if I'm in searching mode, there's only one of two things that can be the case. Either I'm currently focused on the searching view at the bottom, where you're typing into the prompt what you want to search for, or I'm back in my view that was like filtered down. And as soon as you leave that view, we'd remove the filtering that gets applied to it. I think that's fine from a user perspective. You probably would prefer that than an alternative where it lingers, like the filtering state lingers around when you're doing something else. Given that fact, we probably should just be using this approach, where I'm saying, depending on whether I'm actually looking in my search thing or not, like, if I'm looking there, then it's the parent context that's being filtered. Otherwise, it's the current context that's being filtered. And that would make this a lot simpler. So that's one thing I didn't recognize, was that it's kind of silly to think that the filtering would be applying to something that would not be either the current context or the parent context. And even now, I can't think of an example where that would happen. So I feel pretty confident that that would be a good simplification. But I guess we'll see how I feel about it in the next video when I'm actually writing this code. So, what else are we doing here? So I'm saying, yep, searching in context. Yeah, so here I am. I'm still... Okay, so I think maybe in this part of the video, I'm starting to work out that I'm struggling to deal with these two different structs. And so I decide, okay, let's go and merge them all into the one place, and I'm going to have the three different states. There's like, you're not in search mode at all, or you're looking at the prompt, or you're looking at the actual view. And I'm actually still yet to work out whether I need to distinguish between those things. Like, it may be that I actually didn't verify in the code whether I need to distinguish between those two second states, or whether I can get away with just having two states in total. But yeah, that's something that would need to be tested, like verified. And so I'm going through and I'm updating all the code to use that. And what else is happening? So yes, I go and add this into my modes. You can probably hear my brother in the background playing games. Having fun on his weekend. Imagine that. Okay, this thing here, so how do I back up? I'm not happy with these functions at the bottom here. Like, they're kind of tangled, and the naming that they use doesn't really make clear what they're all for. And even I, while writing this code, wasn't really across like what was the different purposes. So like, handle search escape is for when you actually press escape when you're in the prompt. But then there's also search escape, which is, sorry, exit search mode, which is what you would press when you were in the view that you're filtering on. And so that's not really clear in the naming at all. Yeah, so that could be definitely improved. And then there's on search escape, which I'm not even sure why that needed to be a separate method, but yeah, so that could definitely be improved. Am I recording this? Yes. That'd be embarrassing if I wasn't. So then here I'm going and moving all this stuff out into a struct that kind of has full control over its own internals and just has a couple of public methods that it exposes. And to be honest, I'm pretty happy about how this went, because at least then it was a lot easier to distinguish between what is the actual search state that's specific to this struct versus a bunch of other ancillary things that were happening in the GUI side of things. Yeah, it's a bit weird that you've got two files called searching now. I was following the naming convention of the other modes, like diffing and cherry picking, but I do feel like a struct should probably be a noun. So I'm probably going to change that. Also, one of the benefits of having this searching thing in its own package being encapsulated is that at least now I can test it more easily. Although I definitely did not spend much time in this video doing any testing other than that fuzzy search thing, which is partly a problem with just having a God struct. It makes it very hard to find a good place to get in there and start testing. And I've made some progress on that front when it comes to things like the controllers code. But yeah, it's kind of hard when you've got something that kind of touches a few different areas. Although at the same time, it'd be quite easy to create a integration test for this, because you just have to go in there, filter something, and then flick through it and do something, and it's very easy to have that snapshot verify that the filtering actually worked. So at least it has that going for it. And I also feel like integration tests actually, when you're dealing with like a small project like this, I'm actually in favor of being very heavy on integration tests, just because it's not very expensive to just run it in CI. You're not in a hurry. I'm not dealing with like hundreds of developers contributing to a code base and bloating it out with integration tests. It's actually, it's going to take a while for them to become a problem, and you can do many things like parallelize them before that happens. So, yeah. And it also means if you want to refactor your code, which is what I'm currently doing, I'm doing like refactoring to try and break up this GUI struct. You'd hate to have a bunch of unit tests that depend on something that's about to be refactored. Although at the same time, I know that Martin Fowler would say you should always add integration tests, some kinds of tests before refactoring. But if you are going to refactor, then, and you're going to refactor from a very high level, integration tests are the best kinds of tests to be writing before that happens, because at least those won't break from one state of the code base to another. Whereas if you refactor and it breaks all your tests, and then you fix the tests, and then the tests pass, the question is, how can you rely on the tests given that you changed them alongside the code you changed? So, yeah. What the hell? I just restarted this thing. Let's get back to here. Or here? Where was I? It's gonna be so funny if like my brother's voice is like easily noticeable in this video. What am I doing here? Have I already done this thing? Yes, that was ages ago. I should do a review of this review and be like, Jesse didn't really criticize the things that were obviously wrong with the original Jesse's video. He just sat there and talked about random crap that actually was kind of tangentially related. That's probably already been done. So here I'm just going through and trying to fill out the logic, and then my plan was once I have the methods there, I'll go and make all my fields private so they're encapsulated, which I think is a good pattern. I don't know if get search string and set search string were necessary, given that it's effectively the same thing to just go and have a public field, unless you wanted to have some kind of like hooks happening in between, but I just don't think that would ever happen. So, one benefit is you can actually wrap it in an interface. So it has that going for it. Whereas you can't use public fields as part of an interface. Yep, here's me privatizing it by renaming variable names to be lowercase. And we'll probably get to the end soon. I think this is the bit where everything just fails. I have to go and log a bunch of things to work out why. So it would have been good to be testing it in between my more incremental changes so that I can work out what actually went wrong. When you do refactoring, you're supposed to do it in a way where you're basically, well, ideally you'd have like automated tests running in the background, and they would just tell you immediately when you get something wrong. But alas. No, that's probably why I restarted, because I got to the end. Cool. So I rate myself a 6 out of 10 because I was flailing around a bit there, and there's a couple of things I could have identified sooner. I could have taken some compile errors more seriously and just read the messages better, like the one about the low dash sum thing, which I thought was like similar to like the JavaScript equivalent. I probably could have also thought ahead a bit more when I started making a change, but at the same time, it is often good to just go and do it compared to thinking about it really hard and then trying to do it, given that it's fairly easy to throw away code. Like I kind of wrote a bunch of code and then just immediately stashed it and forgot about it when I worked out it wasn't going to work that well. But yeah. Anyway, I'm going to sign off for the night and go and probably eat something. So thanks for watching, and I will see you for the review of this review.